Today is Cambridge Explorers Universe at the Center for Astrophysics at Harvard, and I'm super excited because this is another one of my favorite annual events at the Cambridge Science Festival. And here there are multiple tours of the 1.2 meter radio telescope. There's a great refractor, there's the micro observatory, there's an inflatable planetarium show, there's the plate stacks, and there's even the Solar Dynamic Observatory control room. And there's a bunch of other hands-on activities that are here too. So let's go see what cool things we can find.
Supernova style science news with Julie 7 Sage.
And they have some of the coolest chalk drawings, like the one behind me. It's a life-size drawing of the Chandra telescope, which is one of my favorite telescopes. And this is really cool because this was supposed to be a 5-year mission, and so far it has lasted for 20 years. And I just found out that it probably will last for another 20 years if funding stays. Now that's some great engineering. Seriously, look how big this is! Chandra also has some cool VR experiences partnering with Brown University, starting out with this program which was created by Kim Kala-Arkant. This specific one is looking at a 3D model of the Cassiopeia A supernova remnant, where you can fly through it and learn about all of its different parts. They also have 3D printed models of this supernova remnant and many others. So with a lot of the hands-on activities, there's a lot of things that you can make. So take this for instance. With this, you can measure the path of the sun and make something called a noon curve. But so how you make this is you take a semicircle protractor, you tape just a straw on the top, and then you tie a string through the hole, and then at the bottom you have a couple of nuts for weight. And so how you use it. So you get a shadow on your hand, and you try to get perpendicular to like a north-south line. So you do this, and then you angle it until the shadow looks like a ring, like there. And then you look at the string and see what it reads on the angle of the protractor. Right now it's kind of reading a 32-degree-ish angle, and so that's the angle of the sun. There's also a lot of really cool activities inside. One of them was where you could get your own button with an astronomical image on it. The micro observatory had a setup where you could play around with settings, such as contrast on existing images, and you can even request an image from these robotic telescopes positioned around the world, and they'll email it to you. You can even do it from home. We'll post a link in the description. They also had available tours of the telescopes stationed at Harvard.
Funny at the start. So if you try, I think, reach out for one of these galaxies here. Try and point with it. Point to it. Or that one there. So you see, as you bring it closer, the closer the source of gravity, the more the stretching is of the image, right? And so if you push through it, exactly. So this is actually now, to do that again. So this is not two new galaxies, right? This is the same galaxy that is now imaged twice, essentially. So this is called multiple images, right? And so this is you as this enormously massive object. My apologies, but if I turned you invisible, you would essentially see the same effect.
Like see my arm, like where my head is.
Exactly, that's exactly right. So even though I don't visually see you, I can essentially trace you out. I can trace how you're moving, how you're kind of distributed through space, based on where the light is being reflected and where it's not being reflected.
One of the amazing tours that can be taken is the Harvard glass plates, where there are loads and loads of amazing images taken through telescopes more than 50 years ago. They're images of the moon, of the stars, and of so many other objects. There was so much data and research that needed to be processed, Harvard created the famous group of the Harvard computers. And I don't mean actual computers, they were women. There are hundreds of notebooks with their data and analysis. They also worked on the plates themselves, as you can see by all of the writing on these plates. There are 550,000 plates. The Harvard glass plates contains 3 floors with aisles and aisles of these glass plates, absolutely filled with almost 2 centuries of data. Just look at the amount of plates in a single cabinet. There's also Project PHaEDRA here. So can you quickly explain what Project PHaEDRA is?
Project PHaEDRA is a project to digitize 2,500 logbooks and research notebooks that we have from the 1800s and 1900s, primarily written by women computers who worked here at the observatory. These women did astronomical research looking at photographic glass plates, and they studied how stars change over time.
And these 5 here are some of the main women, right?
Yes, they are. We have Cecilia Payne-Gaposchkin. She discovered what stars are made out of, and Henrietta Swan-Leavitt figured out how far away the stars are from us. And Annie Jump Cannon helped figure out how stars are different from each other and how they change over time.
All right, thank you. Another tour they had was the 1.2 meter radio telescope, which I love to go to every year. The telescope looks at molecular clouds in our galaxy and around our galaxy. It specifically measures carbon monoxide, which this telescope was very instrumental in discovering that carbon monoxide is the best general tracer of the mostly invisible molecular hydrogen found in molecular clouds. The reason why it doesn't look at molecular hydrogen directly is it does not emit the specific radio waves that the telescope observes. However, it can detect carbon monoxide, which is the second most abundant in molecular clouds. This telescope has also been very instrumental in many other accomplishments dealing with molecular clouds. It's always such a fun tour to go on. Especially when they bring out the liquid nitrogen.
And you make it really cold. Really cold. Is it going to be vibrating when it comes out?
No.
Is it going to be?
Yes. It's going to be good. Wow.
Oh my God. The Great Refractor, a historic telescope, was first used in 1847 for visual observations. To end this amazing event, Cambridge Explores the Universe, I am in one of the most historic places in the CFA, and it's the Great Refractor. And I had a lot of fun at this event. It is a yearly event, and I really hope you guys go to it. One of the coolest things about this event is all the volunteers are astronomers, astrophysicists, and other people working at the CFA. And them doing this and teaching kids about space is them showing their supernova style. And hopefully you guys come next year to show yours too.